Hey folks, this is a tutorial on classifying triangles. And I'm just going to focus on breaking all of these terms down, and then we'll look at everything separately and then try to put it together at the end. I know kids are struggling with this. First of all, you have to understand what a scalene triangle. A scalene triangle up here has three different sides and three different angles. So this side is a different measurement from this side, which is a different measurement from this side. If that is the case, and I put these little tick marks in here to show that this is one measurement, 2 tick marks show that this is a different measurement, and 3 tick marks show that this measurement is different from all these, so there's 3 different sides. If it has 3 different sides, then it also has to have 3 different angles. The angles can't be the same if the sides are different. So 3 different sides, 3 different angles. That's a scalene triangle. This is an isosceles triangle. This has 2 sides that are the same. So if these 2 sides here are the same, one little tick mark here shows that this measurement is the same as this measurement. These 2 angles down here will be the same. One little half ring here, one little half ring here show that these 2 angles are the same. So isosceles, 2 sides the same, 2 angles that are the same. Equilateral, this means 3 sides that are the same, 3 angles that are the same. So 1 tick mark, 1 tick mark, 1 tick mark. It signifies that all these sides have the same measure, and one little ring here, one little half ring here, one little half ring here shows that all 3 of these angles are the same. Okay? Now if you look down at all the triangles down below each of these, they all fit in the same group. This one here, it has 3 different length sides. This one here, even though it has a right angle over here in this corner, this is still has 3 different measurements. This one here, all 3 sides are different. These ones here, all 3 sides are different. And you can start to kind of look at them and go, wait a minute. I can not just look at the sides, but I can look at the angles. If I'm not certain, like this one here, do all 3 sides look the same? Well, these look kind of the same, but this angle, and this angle are definitely all different. So therefore, all the sides are different. This one here, I just took and turned them every which direction. Turn this guy over to this side here. I guess we don't have any facing that way, but there's always 2 sides that are the same in every one of these triangles. That's what's an isosceles triangle. These 2 sides are the same, so these 2 angles here are the same. These 2 sides are the same, so these 2 angles are the same. This angle here and this angle here are the same, so this side and this side must be the same. These look like dunce hats to me, and I picture some guy named Isosceles with a little round head. Put a circle here. A little round head with that funny looking dunce hat sitting on it. That's the way I think about it. I'll delete that because it's definitely not an isosceles triangle. Here are the equilateral triangles. I'll just slide myself down. Every single one of these have all the same sides. This guy here is in the wrong spot here. Let me move this over here. This is an isosceles triangle. But let's just take a look at all the other angles. All the angles on every triangle is the same. All the sides are the same. Every single one. Equilateral. Equal sides, equal angles. Okay? So let's take a look and just have you practice here a little bit. I kind of divided these up. I lost one of them. Hang on one sec here. Houston, hold on. Now let's looking at the different angles of a triangle. We can also talk about and sort triangles by the angles. Well, a triangle could have all acute angles. In other words, this here's an acute angle here, and I put a little dotted line in here to show it. An acute angle is anything that's less than 90 degrees. Acute angles. Right angles. It could have one right angle, and I took and showed you what a right angle looks like. Here's the angle right here, and I put the little box in the corner that they usually put down to show that it's a right angle. And then one obtuse angle. An obtuse angle is anything greater than 90, so I put a little dotted line in here to show you that it's a 90. Any angle that is formed that is greater than 90 degrees is an obtuse angle. So look at these triangles that I put down below it. All of these ones here, they all have acute angles in them. Every single one of them. This is acute, acute, acute. They're all less than 90, every single one of them. This one's close, but you can see that that's not a straight line here. It doesn't form a corner. So all of these ones here are acute. Every single one of these triangles has a right angle. Let me just make a little box here and prove it to you. Let's fill it in. Let's make it magenta. Actually, I'm colorblind, so I can't tell what magenta is, but we'll just pretend this is. I mean, you could take and stick it. Every one of them has a right angle in it. It may not look like it. This one here, I've got to turn it a little bit, but it'll slide in there. They all have right angles. They can only have one right angle because a right angle is 90 degrees. If you had two right angles, it'd be 180 degrees, and that's how many are in a total triangle. So you can't have more than one of them because when you add all the angles together, they have to be 90 degrees. All right. These here, every single one of these triangles have an angle that's bigger than 90 degrees. Let me slip it in there. Look at bigger than 90 degrees. This guy down here, let me pivot it. This is going to be bigger than 90 degrees. Here it is. See? That angle is larger than 90 degrees. I'll do one more. This one looks close, so close. But you can see when I slide it in there that that angle there is larger than 90 degrees. In every one of these ones that I've gotten in that column there, they all have one obtuse angle. Okay? So, let's review what we've done so far. You can classify triangles by their sides. Some triangles have three different sides that are all the same, different lengths. Some triangles have two sides that are the same. Some triangles have three sides that are the same. Okay? Review these terms. All right. Some triangles have all acute angles. Those are all less than 90 degrees. Some triangles have a right angle. They can only have one of them. Some triangles can have one obtuse angle. Look at these terms. See if you can remember them. All right. Now we're getting to where things get a little hairy. Now we're going to classify them by both sides and angles. And the first thing we're going to think about is that there are three different kinds of isosceles triangles. You can have an isosceles triangle that has all acute angles like this. Look at these two sides are the same here and here. And, of course, these two angles are the same. And all of the angles are acute. They're all less than 90 degrees. Let me go back and grab my little block here. I'll just copy it. And we'll pop it in. Every angle in each of these triangles is less than 90 degrees. Here, this one here, I'm going to have to pivot, but you're going to see that it's definitely less than 90 degrees. Okay, so you can have a right isosceles triangle. Now, a right isosceles triangle is going to have one right angle. It's right up here. And a obtuse isosceles is going to have one obtuse angle. I mean, let's get my guy here again. Let's just stick it in there and make sure that it is actually greater than 90. Let me see if I can get it. Look at that. There's like 3 people in the world who could have done that. Well, it's a little off, but... Okay, there's me, there's a guy in Zimbabwe, and I think there's somebody in Madagascar, but he may have moved. Okay, every one of these is going to have one obtuse angle. It has to. That's why it's called an obtuse isosceles. All right, so let's just think about isosceles triangles. You can have an acute isosceles. Two sides are the same, but all the angles are acute. You could have a right isosceles. Two sides are the same, but it has a right angle. Obtuse isosceles. It's going to have two sides that are the same and one obtuse angle. That's 3 of the possible 7 triangles. Okay? You could have 3 different kinds of scalene triangles. You could have an acute scalene triangle. Acute means every angle in this triangle is acute. But all 3 angles are the same. It's kind of hard to tell, so I'll put some tick marks on here. See if I actually, I think I'll probably have to write them on. But I think I can write some tick marks on here. This one is 1 measure. This one is a second measure. And this one is a third measure. Let me back that up. This is what happens when you go free. You get freewheeling on these videos. All 3 are different measures. Okay, all angles are acute. This is an acute scalene triangle. You can have a right scalene. Well, all 3 sides are different lengths. I could have used dots, I guess. But it has a right angle. So if it has three different lengths, sides, and a right angle, it's a right scalene. If it has two different length sides, this side is one length and this side is the same length, and then there's this third side, then it's a right isosceles. Two sides that match, but a right angle, right and isosceles. Okay, so you could have an obtuse scalene too. Sorry, so then here's the obtuse angle down here, and all three sides are different, so it's a scalene triangle. So scalene means three different sides, all different angles. All right, and then the seventh triangle really is, let me just clear ink here, is an acute triangle, or acute equilateral triangle. I mean, most of the time we just call it an equilateral triangle. If it's an equilateral triangle, all the angles have to be 60 degrees. It doesn't matter how big it is here. Every angle is 60 degrees. Every angle is 60 degrees. Getting kind of crazy here, but take a look. The angles never change. The sides are all the same. The angles are always the same. Doesn't matter the size. So this is an acute equilateral triangle. Let's review a little bit. Isosceles triangles. Isosceles triangles have two sides that are the same. It could have all acute angles and be an acute isosceles. It could have a right angle, which is a right isosceles. It could have an obtuse angle, which is an obtuse isosceles. Okay? I think isosceles are the easiest ones. Two sides that are the same. I think this is the next easiest one. Equilateral. Everything's the same. Sides are the same. Angles are the same. Scalene gets a little trickier. So here it is. Scalene with a right angle. That one's pretty easy. All three different sides and it's got a right angle. It's just really these two here. But it's either going to be obtuse and have an obtuse angle, or all the angles are going to be acute. So these are the 7 different triangles when you classify them by both sides and by angles. I know it's kind of a tough concept, but we've got to get this down. Let me just give you one more shot here. Let's see if you can take these scrambled triangles here. I've taken them out of their places. Can you put them in the proper spot? Where are you going to put the yellow triangle? Yellow triangle, all sides the same, all the angles are the same. That is an acute equilateral triangle. Okay, do all the right angled ones first. Those are easy. Okay, this has got a right angle. Where's it going to go? Right scalene. 3 different sides. It's got to be scalene. How about the other right triangle? You see the other right angle? You betcha, right here. Let's just turn it to make it look even more right. Okay. 2 sides are the same, so this is a right isosceles. Why don't you do the rest of the isosceles? How about this guy here? Here's an isosceles. 2 sides are the same. Where's it going to go? Well, are all the angles acute, or is there an obtuse? They're all acute, so this is an acute isosceles. Okay, here's another isosceles. Well, these 2 sides are the same, but this angle is bigger than 90 degrees, so that has to be an obtuse isosceles. All right, we've got 2 left. We've got this guy here, and we've got this one. These are the 2 tougher ones. All 3 sides are different. We have acute scalene and obtuse scalene. To me, it's really easy to see the obtuse angle in here, this big obtuse angle here. So this has to be obtuse scalene. And this guy here, with 3 different sides and 3 different angles, this one has to be acute scalene. I think that's the hardest of the bunch. I hope this helps. I appreciate you listening. Tough target. But you can go through and listen again and maybe really focus on these first 2 pages where you learn the difference between scalene, isosceles, and equilateral. And then what acute, what right, and what obtuse mean. All right, good luck.